So now let's look at how we can get our transistor or MOSFET operating as a switch. So when there is 0 volts or insufficient voltage applied at the gate, 0.8, the switch is considered open and there's no connection to ground. When we apply sufficient voltage, in this case it's approximately 2 volts or greater, the switch is considered closed and we have a connection to ground. So when the switch is closed, we get the answer 0. When the switch is open, we get the answer 1. This is nMOS. Now for pMOS, the exact opposite, if you remember, occurs. So if there's 0 to approximately 0.8 volts applied at the gate, the switch is considered closed and we get the answer 1. When the switch is considered as open is when we apply sufficient voltage, which is approximately 2 volts or greater. The switch is considered open and we get the answer 0. So here is a voltage graph and we get the answer 0, or the logical value is 0 when the output voltage is between 0 and approximately 0.8 volts. We get the answer 1 when we get between 2 volts upwards. And here is the nMOS representation. When the gate 0 volts or a 0 is applied, the switch is open. When we apply a 1 or sufficient voltage, the switch is closed. And for pMOS, it's the exact opposite. So I'll just make a note of that. pMOS opposite to nMOS. I wanted to mention this area called undefined, and that's what we've called an area between approximately 0.8 and 2 volts, where we don't know whether it's a 1 or a 0, because the switch could be switching upwards because it takes time for the switch here to operate. Also, these areas here, 0.8 and 2 volts, is what we defined, and they're dependent on the type of transistor or the values or the spec sheet from the transistor or the MOSFET that we've created. So we've defined 0 to approximately 0.8 volts as equal to the logical value 0, and we've defined 1 is equal to approximately 2 volts or greater to equal the value of 1. Here we're assuming, well, we're going to use 5 volts up here for what we create later on as their source. Also, the other thing I'd like to mention is VDD is the voltage between the source and ground. When you see the second D here, or the second, say if it's VSS for example, the second S, instead of putting ground, we're measuring the voltage between source and ground. So VSS is equal to, say, 5 volts. That means what we're actually saying is that we're measuring the voltage or the potential difference between voltage of the source and ground. And same goes for VDD. The second D tells you that it is connected to ground.